Now let's look at example 3. Under certain conditions, the rate of cooling of an object varies with the difference between the temperature of the object and the room temperature. Given that the temperature of the object at any time T is theta and the constant room temperature is theta naught. So the model is d theta over dt is negative k theta minus theta naught. So we have negative here because this is a cooling problem. So there is a decrease in the temperature. So K is a constant. Given further that the room temperature is 20 degrees Celsius. So the 20 degrees Celsius here is the value of theta naught. So the first question is to find a general solution of these differential equations. And then for B, if it takes 12 minutes for the object to cool from 100 degrees Celsius to 50 degrees Celsius, find the time taken for the object to cool from 50 degrees Celsius to 25 degrees Celsius. So let's find the general solution first. So this is the model. Since theta naught is 20 degrees Celsius, so we have d theta dt equals to negative k theta minus with 20. So now I'm going to separate the variable. So we have d theta over theta minus 20 is equals to negative k dt. And then as usual, I am going to integrate both sides. So integrate theta minus 20, we get ln theta minus 20. And then integrate negative k with respect to t. It is negative kt, and don't forget to plus with c. So let's convert this to exponential form. So theta minus 20 is equals to exponent to the power of negative kt plus with c. And then we have theta minus 20 is equals to e to the power of negative kt times with e to the power of c. And then let's convert e to the power of c to become a. So now we have theta minus 20 is equals to a e negative kt. So our theta is equals to a e negative kt plus with 20. This is our general solution for the model. And now of course we have to find the value of a and the value of k. So let's look at our question. What is the information given here? So if it takes 12 minutes for the object to cool from 100 degrees Celsius to 50 degrees Celsius, so that means when t equals to 0, the theta is 100. And then when t equals to 12, the temperature cools to 50 degrees Celsius. So these are two information that we have, which we can use to find the value of a and the value of k. So we start with when t equals to 0. Our theta is 100. So we substitute into the general solution. So we have 100 equals to ae to the power of 0, because when t is 0, so it becomes e to the power of 0, plus with 20. So 100 equals to a plus 20. That means our a is equals to 80. And then let's use another information. When t equals to 12, our theta is 50 because the object is cooled down from 100 degrees Celsius to 50 degrees Celsius in 12 minutes. So we substitute into our general solution. So 50 equals to, now we have the value of a, so we can use it. 80 e to the power of negative 12k, because our t now is 12, and plus with 20. So we have 80 e to the power of negative 12k now equals to 30. And then let's solve to find the value of k. So we have e to the power of negative 12k is equals to 3 over 8. And ln both sides. So we have over 8 is equals to negative 0.9808, and here is negative 12k. So the value of k is equals to 0.0817. And let's resubstitute our k and our a now. So now we have theta is equals to 8t e to the power of negative, and the value of k is 0.0817 t plus wave 20. And then let's find the time taken for the object to cool from 50 degrees Celsius to 25 degrees Celsius. So to do this, first we are going to find t when the theta is 25 degrees Celsius. So 25 is equals to 8t e to the power of negative 0.0817 t plus with 20. And then we have 8t e to the power of negative 0.0817 t is equals to 5. So let's solve this. So we have now t equals to 33.94. So 33.94 is time taken for the object to cool from 100 degrees Celsius to 25 degrees Celsius. So what we want is for the time for the object to cool from 50 degrees Celsius to 25 degrees Celsius. So what do we have to do is we have to subtract the value. So we know that time taken for the object to cool from 100 to 50 is 12 minutes. And we know that time taken for the object to cool from 100 to 25 degrees Celsius is 33.94. So what we want is the value or the time taken for the object to cool from 50 degrees Celsius to 25 degrees Celsius. So what do we have to do is we have to minus. So we're going to take 33.94 minus with 12. So the answer will be 21.94 minutes. So 21.94 minutes is the time needed for object to cool from 50 degrees Celsius to 25 degrees Celsius.